I hope I'm recording. I hope I am. Hmm. Not too. Well, I don't think so. By request by Charles Crawford. Hello, Charles and friends and people and hobbits. Whoops, what are you doing? Hold on. Okay, something going on here. Anyway, uh, others to study would be the device of Hans Kohler, which George Hathaway built in Toronto when I was in Toronto with George years ago, involving magnetics. Also, Wilbert Smith, this famous Smith coil that has crisscross flat windings on it, on a ferrite core, is something to look into. I'm getting weird readings here as well. But I know that there are a lot of fake stuff out there all over the place, hundreds of, not thousands of so-called free energy devices. One of the tricks I like to use is a diathermy machine, which is under the table, makes things light up and move. That's one trick they like doing. The other is, of course, the invisible wire stuff. Hmm. Unfortunately, now I'm sure there's a lot of folks like you, Charles, and the alchemist fellow, and many others are really doing excellent research. So that's why I decided to make another video for you folks, so you don't get caught up in the whirlwind of crazy people out there on the internet. Now, as I mentioned before, Nikola Tesla is very worth studying his stuff. It's solid, strong. I hope you can hear me. It's so bloody noisy out there. So yeah, Tesla and Henry Hertz and all the old timers are very worthy of studying. Okay, so other than that, there is probably a lot of stuff that's been done that's kind of forgotten about. Now, the QEG, quantum energy, what is it, converter or something? The only ones I know of is Dr. Franklin E. Mead's device, which he has a patent on December 31, 1996. And I was following that for quite a while because IBM was buying up all the patent rights to it. You want to check into that. Dr. Franklin E. Mead. I'm sure there's others. Peter Kokoschnik was on the verge of. I was there when he's doing it, on the verge of making something. And he was collecting the ether oscillations, and his publications are ether oscillations. He's into that big time and knew what he's doing. It seems to always involve round spheres for collectors, which is interesting. There's something there. Maybe there's a correlation to the DESI documents in Germany on that. I don't know. But I've seen it before in Electric Spacecraft Journal, where the U.S. military folks had these hollow cylinders, big hollow cylinders of barium titanate laid out on the ground or on a special platform. And there was four of them in a square, okay. And there was a fifth one in the middle, which apparently levitated. Written up by Charles Yost, Yost, for Electric Spacecraft Journal. If you can get old copies of that, it's worthy of studying. I know I'm written up in it as well, but and I drew out diagrams and they wrote all that up for me. T. Townsend Brown is real. Oh yeah, he's done the lifter stuff many times over. T. Brown, and others that are into that lifting effect with ion high voltage stuff. Now, what you're showing me about what's his name, I can't remember it. Chet Kanakinoff or something. I have no idea what that thing is. Somebody posted a comment that it was compressed air that drives it. So I don't know. Now I get suspicious when they do not allow people to look at it up close, examine it, and test it. Okay. He should have filmed it up close, had somebody there to test it, verify it, maybe a local scientist or in somebody anyway. A lot of cases it's never like that. It's all fake. A lot of stuff shown is fake, and when they start talking about the government was after me, that's all garbage, because government would be very helpful in this kind of thing. The Department of Energy, DARPA, all those names. Because I submitted to DARPA and they're quite friendly, and no government. Government did it. Yeah, right. Number one, they're not allowed to do it. Number two, they must look for new energy. I got a nice letter email a long time ago from Major Peter Garretson of the U.S. Pentagon Air Force Division on one of my power cells. He was Chief Procurement Officer for Technology for the Air Force. And I kept in touch with Peter Garretson for a long time, just to let him know things that happen, as well as Colonel Alexander. And who else? Others, military scientists. The proof is in making up a few of these things, whatever you're going to be doing. Give them away. Give them away to the audience. If you give them a lecture on it, that's what I did in Japan, for Pete's sake. My stuff is not that unusual. It's kind of based on principles. That Kyoto Institute of Technology analyzed my stuff. It's really not that weird, but people are interested in it. It's not really free energy. I don't call anything free energy. Look up the Oxford Bell. That is a classic device that's been running for a long time. Oxford Bell. Perhaps it's a Zamboni pile. Nobody knows yet. Speculation, but it's running. So a lot of these technologies go way back in time. Now, some other technology, which is interesting, which is drawn out to me by visiting contractors from for the U.S. military industrial complex. Going by memory, I think it's what I drew up here is pretty accurate. So, if you're interested in this, it's called a military battery replacer. It's either proposal or I don't know if it exists, but you can take a look at it. Now, somebody could build this quite easily, actually, if they got patience to do so. It's a D-size cell, and how it's built is this. Oh dear, I'm becoming a teacher, aren't I? Oh dear, oh dear. All right, let's see if I can do this. I know this is very primitive for you compared to other people that do great presentations. I'm just a basket case. Anyway, this centerpiece is an iron rod, or special iron rod, or magnetic material. Okay, this is fine windings and number 40 gauge wire around this. Okay, and of course it'll be separated from that. You don't want wire touching each other. This up here, here. This is the cross section of the military battery replacer. Okay. Up here are capacitors, low inductance, very low inductance, very Interesting. Now, okay, we could build that, right? You could build it. I don't want to build it. I built a lot of weird things. Anyway, so what we have here is this button, which I'm told is junction barrier technology, okay, which will resonate somehow this iron rod. Now, I did come across material that was at 5 cycles per second rock material that I analyzed for Alexis Pizarro, and it was 5 cycles per second oscillations of a magnetic field, so perhaps this is quite feasible. Power output, I'm sure, would be not that great as an ordinary D cell, chemical D cell, but if you can figure out this, I know transistors, I studied them in junction barrier tech. Perhaps a tiny bit of electrical current's produced that excites the iron rod or something similar, but that's the key. Now, this was drawn out by a contractor, as I mentioned, 1993. All right. God, I wonder if it's barium titanate. I doubt it. But anyway. And it was confirmed by U.S. military in Ireland through a phone call years ago. Do a screenshot of this. I'll try and make it look presentable. Okay. Screenshot it. All righty. Now, yeah, that is kind of intriguing. That is. Got a ring of truth to it. The inner voice, So, yes, I made alternative energy devices for customers. As I mentioned before, they were barium titanate cylinders for radio trade, and then later on it was for Japan and Germany and others, which they worked and were tested. I got a video where one of my sponsors or business partners tests it for endurance. Plus, they're X-rayed. Gotta show there's no batteries. In my opinion, you can take the whole darn thing apart. And in Japan, I did sell off a whole pile of small ones I made. Because Brian O'Leary was selling his book. Dr. Brian O'Leary, a good friend of mine. And I said, well, can I sell off these demonstration pieces? And my host said, yes, go for it. Of course, I made him bigger ones, but this thing is moving, I think. Moving it is. Wobbly dicky. Alright, let's try and get that up there so it doesn't. I'm gonna stay there. I didn't know, but anyway. Excuse me, quantum energy converter? If it's involving motors and magnets, forget it. You got to have good knowledge of magnetic fields and magnets. Why is that moving? It is moving. Oh, wow, cool. Okay, so. Because after all, we use magnetic fields to keep matter and antimatter separate. So, what I built for Germany and Japan was barium titanate, resonated at 18.5 kilohertz with crystalline structures. And then I always tell my, this is weird. Oh, this thing is moving again. Oh dear! Can't have that. Right. Moving like so. Maybe that works better, I don't know. But this is how I approach people that are interested wanting things. Now, mind you, I never promote anything. There's always people saw a TV show or something and wanted something. I'd explain I could build you something, but there's failure. It could fail or it's low voltage. Now you can take it or leave it. I don't care. I got other things I got to do. So they took it and built some really good ones that are in Hiroshima City and over in, I think, Hamburg. I think Roland Brito has got a pile of them as well. We talked for 24 hours on the phone. I think it was 2006. Roland got these things and he's explaining how they work and all that because he takes everything to the Max Planck Institute or to Berlin Laboratories. Have it checked, as well as my sponsors in Japan would take it to Kyoto Institute of Technology. The operator was Mr. Ojiwara, and I have all his faxes in that pile of papers. But anyway, so here we have a demonstrational piece, a barium titanate. Is we going to work? Is it off? Oh, some upset raven outside. Okay. So we're getting millivolts and milliamperes and that kind of thing. This is the barium here. Let's see if it changes at all. I can't see anything. So this is a barium titanate plate. It's called ruggedized. This is steel, stainless steel around the barium plate in here, and it's got rubbery material on the top, which is clear. This is a U.S. Navy sonar detector unit. It is basically barium titanate. And let's see, we got something here, okay? So I'm going to move it around a bit. I can't quite see that, but I'm going to press on it. That definitely moves around. These things make good detectors for looking for things. Let's see, put it up against some metal here and see what happens. Take it away. Oh yeah. Move it around. Lift it up. Very sensitive. So what's barium titanate? Basically a transducer, and what they do with transducers is they add formulations of other materials. There's ferromagnetic properties, piezoelectric properties in these things, and there's combination of doping agents and other things that produce electrical energy. So nothing really new about it. It's been around since a long time. So I had the cylinder version of these. They're big cylinders with this glass wool spun around the whole cylinder. Say about 1950s, 60s. Out of a sonar, I still got one here. I gave one to Inventor 3, who tested it and played with it, and did a video on it. Now, okay, so this is a basic primary energy source. Then I think, wow, that's kind of intriguing, isn't it? So how do I amp that up? Well, I used resonating crystals. I got them made at Surak and Goodfellas. They're crystal wafers, 30 of them, about 30 millimeters in diameter, going by millimeters, frosted with hydrofluoric acid that they used. I didn't do it that. And coated with special materials, non-electromotive. or battery stuff. Not, no, no, no. Are you familiar with cat whiskers and galena? So that's intrigued me to build something similar with these wafers. That has them sharp points, micro points on them. So it'd be an interaction between them all. And it worked fine. I mean, got the idea from reading about galena and cat whiskers and naval sonar systems. It did work. I mean, I made a number of them. I had them make me a whole stack of these things. So I sent them to Japan with the barium cylinder or one of these in it as a main exciter. Plus some electronics, which I gave away to Dr. Marcus Reed. Little energy in and high voltage out device. I have no idea what it is. Something found on the warships. I got shocked from it, thrown across the room, basically. And I got shocked from these things, too. But I'm thinking of putting this in the lathe and cutting that off and get the plate out, but you just do it with a cutoff tool. Parting tool. God, that's rugged. They use them for also for surface analysis of the water and send signals into it and send signals out, of course. So there's very exotic technology. The old naval sonar systems. Prior to that, it was Aztec. So, covering some of the free energy stuff today, as requested by you. There's Fogal's transistor. You want to check that out. Fogel. Fogal transistor. He's done a lot of research on certain transistors, made his own. You may want to study T. Henry Moray. My personal opinion is that long antennas will produce a lot of voltage from ambient electrostatics, as Art Bell proved in his device in Nevada. We talked on the phone for quite a while about it. I had to hire a helicopter to put the wire around this big system he had on his property, and he had a knife switch, and he said it would spark a lot of energy. So perhaps Moray as well had a way of boosting like I boost this up. And during geomagnetic storms, of course, you're going to get a lot more energy. Solar flux index, check that out. At 2 gigahertz, if you have a spectrum analyzer, you can watch it, or radio, and you can listen to it. Geomagnetic storms are so strong that you can actually have disconnected radio speakers humming at about 20 to 30 cycles on their own without any hookup. And yes, indeed, radio speakers or speakers are a energy source if they are touched or moved. So always you need a prime mover with a lot of your goodies. Now, if you had a big radio speaker, lots of fine wire in it, have it just sit on the ground or inside in the basement or something, you'd pick up energy if there's vibration or geostorms or whatever, even wind. But it's not a lot. I mean, everybody says, oh, I got something I got to power a house with. Yeah, right. I don't think so. Not yet. It's always low voltage or even high voltage, but not much working energy to do anything. Anyway, other systems. Let's see. I took a copper nail. Oh, I learned this from Jerry Gallimore's book, Unusual Earth's Unusual Energies. Okay, that's a good book to get a hold of. Goes in a lot of different things, like a copper nail, copper coated nail, put into a tree and a long wire to it, and you get some unique energy if you add capacitance and capacitors and stuff like this, which I did do, and I got working energy that worked a small motor, a little thing like that. It was connected to a big Tesla coil, and I used vacuum capacitors, glass type vacuum capacitors. I think George Hathaway got to check it out. Alex Pizarro and I were playing with it, and then George showed up one day and he was testing it, or I think he was, or Pizarro was. It put out a good energy. I mean, small amount, but to drive a radio or a small little motor like that, that was, Guy Lordy, that was a long time ago. But that energy from trees, of course, that works good. Other magnetics, of course, you're looking for things that you don't need prime movers for, I think. Um, was it cow magnets? That's what cow magnets was what Hans Kohler used, and that's what George Hathaway used in his Toronto lab. Whether anything, George felt it wasn't doing too much at that time. He had a few other devices he was working on too. As I mentioned, Bob Greener and George Hathaway are probably the world's foremost investigators of all these things. And George's been at it for a long time. So I hope this information helps. And if you're wondering, you can still do a screenshot of this and let me know what you think. I got it right here. That's simply that little part there is the key to driving that core. Was I talking about the magnetic rock? Yes, I was. I kind of drifted off topic on it because later Pizarro gave me a chunk of it. And Roland Brito, who was visiting us in the 80s, put a string around it and hung it off the back of a chair. And it would sometimes spin around. And Roland was fascinated by it, so I said, you can have it. And he took it to Germany. Now, Roland and myself and his brother are written up in Esquire magazine. Quite a lengthy article, 4 pages. And I have a copy of that magazine. But Roland is brilliant. Anyway, so that's some of the stuff I'm talking about. What other things do I know about magnetics? Besides conventional stuff. Well, I do like magnet motors, but not what you think they are. Not free energy, but for driving a lathe like that. I use a variac with a bridge rectifier in there. I love old DC motors. They're awesome, man. The real cast ones. I got one in my computer. My target designation unit from 1943 off a warship. It's got a DC motor and like that, big and solid cast, and man, that thing is powerful. And I have another one. It's about 100 pounds, and I'm going to try and find more of them. Induction motors are good for their purposes, yes. Capacitor start. Hello, what's beeping here? Gone overboard. Oops. Hold on. These things build up a charge, by the way, so you gotta be careful when handling them. These barium titanate things. Anyway, yeah, that's so yeah, that was something. And I came across other self-reactive materials like capacitors that are described to me by an engineer from General Electric. This is after I got almost shocked right through my head. I was in Uncle Pete's basement on Main Street, Satellite Electronics on Main, and he had these two big capacitors. Nice long insulators, and I grabbed them and bang! Like that. Oh! So I took a screwdriver from Uncle Pete's toolbox and ran it across the terminals and it'd get bang, you know. Oh, that's fascinating. And I did it again and again and again. Oh, must be self-reactive, which was explained to me by an engineer from General Electric who's explained that they take canuba wax or materials or plastics and that, heat it up until it's into a steam state. So if it gets in a steam state, it goes through a condenser, whereas extra high voltage direct current around it, and it kind of collects into the actual capacitors as the electrolyte or whatever you want to call it, or insulation material, and they produce their own voltage. My other partner and I would look for these things as well as self-reactive diodes, and that's Alexander Shereshevsky, who was my partner at the time. We go to Uncle Pete's and go through a dollar table, and we'd find them, and we had a lot of fun with those witchy energy things, as Alec calls them. We made all kinds of detectors with it, and power sources, small ones. However, it was funded by Boeing. Aaron Kovacs, a Boeing aerospace company in Seattle, funded all three of us. There's Alec, myself, and George Lissicase. It was rough with Georgie, though. He was nasty. He was always nasty. Anyway, we had a lot of fun testing this stuff. And when things broke apart with us, not with Alec, but with George, I'm still in contact with Alec. Georgie made what he called a field stress detector for finding water, minerals, oil, gas. And actually the field stress detector actually was, the Pizarro family owned it. It was Alexis Pizarro who unfortunately lent it to Owl Industries in Vancouver that tested it and stole it from Alec. Pizarro. There's Alec Pizarro and Alec Shereshevsky. Hopefully Alec and I will meet sometime. I'll be meeting with hopefully Thomas of the Messer Gas Company again. I made him a bunch of devices, and I keep in communication with him, as well as Alexander and George and others. So all in all, it's kind of fun stuff, I guess. And anyway, that's some of the stuff that I can make suggestions on certain individuals. I'm sure there's many others I forgot about, or so many darn interesting things out there. There is a report done on zero point energy that interferes with the manufacture of barium titanate. Used to copy and paste all these articles from the internet and post them on Blogger. Blogger is John K. Hutchison .blogspot.com or something like that. Waiting on the edge of forever. It's an endless number of blogs. I have no idea how to work them or even find all the articles. But you're welcome to break into it and see what you can find there. Doesn't bother me and I could care less, but because I forgot how to even use that. I forgot the password to it and all that stuff. Started doing that in when? 2000 something. I was very crazy with a computer when I first got a laptop. I didn't know how to use the stupid thing. Now, once I got on the internet, there was Yahoo and all the nice dating sites. Woohoo! So I had a lot of fun dating. I'm trying to remember when YouTube, 2006, something like that. I had dial-up. I had a YouTube channel as well, I think. Yeah, I did. I had to have one. I did a oops with one video I uploaded by mistake. It's oops. Let's say it's this. Sex Lies and Audio Tape. I was noticing it getting a lot of views. I said, oh no, I didn't want to upload that. It was a mistake. So luckily I deleted it real fast before YouTube people came around and banned me. So later on, I still have a YouTube channel. Hutchison 2009 or Hutchison Spec 2009. I got bits and pieces of junk on it, but then I got banned for having too many tags or something. And then a friend of mine that works at Google managed to get me onto the channel I'm on now. Which, who knows, it could just go away. Be blocked or banned or fall apart or who knows. But anyway, I encourage you all to simply copy these videos. Any of them you want to copy, I could care less. Not public, so take them and copy them. I don't know what's worthy. My Willis Ravens are the best ones. Look, I can't keep them backed up. The Willis Ravens. So I'm wandering around the circles again, aren't I? Oh well. But shall we test our bariums again? Turn this on. No, the voltage will drop because it goes between negative and positive. When you get to negative 0, 0, 0, but this is what it's reading right now. And so I touch it or move it. What I did to do there is squeeze it. Interesting, huh? Simply just touch it and squeeze it. Let's see. All over the map, isn't it? I could safely take a hammer to this because it's ruggedized. I got a hammer. Let's see what happens. Okay. Okay. That's interesting, isn't it? See, I'm doing this to it. Now, what I'll do too is take a pair of big vice grips and squeeze the whole thing. Like these. I'll put that there and grab onto it here. Stick that thing away. Like so. The other thing you can do with this stuff is put power and feedback. You run this to an amplifier and you take the microphone, put it right by it, and it produces unique things that's seen on TV. Okay, now I'm going to squeeze this and see what happens. Alright, now our reading is what? Ooh, overload, overload. Release. Squeeze. Wow. That's why I'm squeezing it with these. So I get a reading when I squeeze it. Which is nothing unusual about that. It's just the way barium titanate is. Okay, let's try that again. So active, this stuff. It's amazing. Squeeze. Let go. Squeeze. Let go. It goes to oil overload. So it's working the negative and positive of the characteristics of this stuff. Squeeze, squeeze. Do fast squeezing. Yeah, so that's what I'm doing. I'm squeezing it right there. Okay, so good demo. Also, you can put this in the sun. It'll produce a lot of voltage, or put it in the freezer. It'll produce a lot of voltage. And I know from experience handling it. Like, bang! Oh my goodness! We did 43 minutes talking. Hi, Bones. Time to act silly or not? I think it's time to act silly, don't you think? I don't know if I helped you guys out. I have no idea. Number one. So, okay, we had fun today. Hi, Barbarella. Whoa, let me stretch for a minute. So what else am I doing? Hello. So that's a lathe I built out of scrap. All scrap, basically, except for the centerpiece, which I bought on eBay. Just for the challenge like they do in Pakistan, really cool engineering tricks. Actually, I would probably, if I wanted to learn something, I'd go to Pakistan and watch how they repair things. They do amazing work. Cutie patootie. Time to act silly. Break time, huh? Okay, so let's take a look. I'm sure it'll work just fine, this thing. I have, I'll try it out tomorrow, I think. Added a switch to the motor, and I gotta get a new capacitor for the motor because it hums. It's kind of intermittent, so it's old capacitor kind of thing. Problem. Yeah, electrolyte dries out or goes wonky on you. Speaking of capacitors, we could disconnect this and look at some interesting materials. No, it doesn't disconnect. Okay. Take these wires off. Now, see how it goes down to 0, 0, 0. Disconnected. But we could show you something that is interesting. Sitting too long. Look over here. You've probably seen this before. So let's go on the floor with this. Oh my goodness. Where are we here? So let's see. So let's try and get a reading off these guys. If I get a reading. You see that? And nothing? Oh, nothing much. No, nothing much. Take it away. No. I noticed that with these guys. It comes and goes. It's very heavy. That one. Let's go to the far side. There's. What do we got here? Oh. Yeah, it's got electrical energy, but not much. I go to center one then. It's intermittent. And I can charge them up with a 9-volt battery. These are, let me turn this off. These are power factor correcting capacitors for substations. And Bipro number 2 impregnated flashpoint 148 centigrade contains no PCB. These I got at a local scrapyard. So. I'm gonna put them in series and hopefully get more of these things. I can't find any low inductance plasma capacitors like I used to have. I don't know where they went to, but oops. Hold on a minute. Number one. Let's look at capacitors. Sorry about that, but nature does call. Number one. Let's see. Put that there. And put this up here. Where was it? It was over here. Put this away. Okay. Turn off. It's turned on. So I'll be making some unique fields. Speaking of magnetic fields, but it's all powered. Oops. By prime mover, which is going to be a lot of amperes. What's going on here? So that's my little spiel for today. Let me know if there's any questions. Hello, what's going on here? Oh, nothing. Oh, good afternoon. How are you doing? Hi. I am a owned pet. Those guys own me, I think. They're the reason I'm here, actually, because the others with me decided to stay here because of those guys. Wherever they went to looking for things, land and properties, the ravens will always show up. And I guess they own me and own the others. Yes, I know. I talk to them. I talk to animals all the time anyway. And I wind up sitting, animal sitting sometimes. Well, I guess they just wanted to say hi and that's it. Isn't that right? Hello. Hi. Oh dear. Nice day today, so spring has sprung. Those guys, ravens, they love walnuts. Walnuts! Yeah. We did 54 minutes. Should I try for an hour? I don't know. Ooh. Good. So have you guys tried synchro motors? That's a whole science forgotten about now too, I think. Synchro motors are in this unit here. That's off a warship sighting device in 1943. And I have over here synchro motors as well. Are you guys all hidden in here somewhere? Transmitters and receiver motors. This is old tech. Oh yeah, here's something. Example of a synchro motor. That's off HMCS Columbia. It was in their main sonar unit. And it's actually on video on the X-Files. You gotta look for it closely though. This is in a large front panel. And I took it out of the panel. God, I wonder if it's got any of the original X-Files paint on here. I don't know. It says sonar. Here we go. Bing. If only they knew about this piece. HMCS Columbia. I've got some cool diagrams on these synchro motors. Move it around a little more. So there were 2 films done on Columbia. Dodcom and Endgame, X-Files. And I'll put Mr. Sonar piece part up here. Should have kept the whole sonar thing, but it's one of those stress times in life. It's on display up here, and then I have one here that. Oh yeah. Put this here. The X-Files paint, as I call it. Hold on. Put you by the knobs. Not the knobs, Bones. Yeah. Get out of there. So, this was used, let's see, let's go over here. Let's go over here. Hopefully you can stand me for an hour like this. Put you down here, put this up here. And plug it in. There we go. Can I hold it without getting electrocuted? So this was out of the computer targeting system. Read down here. Seconds. It does have the original X-Files paint on it. It's a darker color. Wow. So this is out of the computer in the bottom of the ship for the 3-inch 50s and 3-inch 70s computer designation system. Columbia. Unplug it. Still smell it. Nice. It was Shirley Ingram who guided her painters to paint everything a darker color on the warships. And I have other parts too. But anyway, you should look up synchro motors and all that cool stuff. Here we have more pieces and parts. Oh, most of this stuff. I had a switch in the sonar unit. I guess not. Mounted in the ops room, above your head, actually. These things work. Okay, so I guess I did an hour, right? Right. communication system. If needed, I can communicate 100 watts out, up to 30 megacycles. And I don't think you've ever seen these. Number one. These are portable 36-pound backpack unit radios, 100 watts each. So, just hook it up to a DC power pack or batteries, and I can communicate. Hello! I did communicate to a ship from Vancouver, as in Vancouver to Hawaii. They were doing an emergency operation. So these things work well. Out of a pair of radio sales in 1994. And then we got one of these. This is a modem for a radio teletype. Vintage. And I do have that radio teletype typewriter over here. Take a look here. It does work. So that's RTTY vintage. Anyway, I'm going to go. It's been 1 hour and 3 minutes. An epic video talk. I hope you learned something. If maybe I did. I don't know the answer, but it's fun doing it. So remember, you might have an idea on how to operate that. I have an idea, but it doesn't matter. I'm not that interested in it. But okay, thanks a lot. Cheerio.